Hello. Today, I will be showing you a quick demo of an application for simulating dynamic systems using block diagram. To start, head over to the GitHub page. I will be leaving a link in the description. You can use this application to simulate simple systems like a pendulum or a heater in order to tune the response of a PID controller. It is also an invaluable tool for systems courses. There is a linked documentation that you can refer to later for more details on each part. I will keep this video brief so you won't get bored. There's an online version available so you can use the application directly in your browser without having to download anything. But it won't save your work to disk or anywhere. All your data will be lost when you refresh the page. To download the app, head over to the Releases section. I will be downloading the Windows version, but there is also a Linux version available for download. Once you open the app, you'll see an example project. Simply close it and open a new tab. To add new blocks to your screen, open the palette in the right corner of the window. We will first visualize a simple ramp block on a scope. First, open the Sources category and drag the ramp block. Next, go back to the sync blocks and grab a scope block. You can connect them together by dragging from one socket to another. To run the simulation, simply press the Run button in the toolbar. You can open the log at the bottom to find out if any error happened. Now that the simulation is successful, double-click the scope block to view the simulation result. You can pan and zoom the viewed plot from the tools in the toolbar. To delete any element, you can click the element, then press Delete, or you can hold down Shift while clicking to temporarily change your mouse to the Delete tool. Now, grab the gain block from the Math section. You can customize its gain from the Properties dialog, which you can open from the toolbar at the top. After we wire up the connections, we can see the ramp on the scope has changed its values. There are many blocks that you can choose from, but these may not be enough to cover all use cases. You can create a custom block using the Lua programming language. The simplest block you can use is an expression, which takes inputs from the letter A to the letter F, and also time represented by the letter T. This is parsed as a Lua expression. As you can see, the output is now a log function, which wasn't available in the math section. Lastly, to fork an existing connection, you can use the Net tool from the toolbar, or you can press left control to temporarily change to the Net tool. We can now see both the input and the output of the expression block. Now let's create a more complicated example, a first-order feedback system. We can use a step source to get the step response of the system. Then, we add a controller that's an integrator, and run a negative feedback loop around it, using a gain block of a negative gain. You can easily rotate or resize a block using the handles around it. After running the simulation, we can see the characteristic step response of a first-order feedback system. We can increase the feedback gain to further increase the bandwidth of the system. We have reached the end of this video. Thanks for sticking around this long. I am looking forward for your feedback to further improve the application.